New panelist is a Dutch guy called Dominique from Innexo. Thank you, welcome. Vamos. So Innexo did what we were planning to do in the Cannabis Hub 6 years ago. He's a passionate of the cannabis plant, and he's a mastermind, a scientific that really loves doing science and cannabis, and he has been so smart to have a super amazing place in the Netherlands where I encourage you to visit him and to check what he's doing because he's amazing. There are a few new articles talking about non-veggie and many other ones that I think we are going to surprise, and perhaps we are going to see something about it. In any case, he is coming to show us the future of the cannabis cultivation, and I'm sure we are going to learn a lot for him. Think that we have laid down the pincho pote, and I want you, all of you, connect and being able to, I think, do future collaboration. So thank you, Dominique. Let's go ahead.
Thank you, Senor Ruben. All right. Thank you. Great being here. They finally let me out of my facility. So, what better place to be here today than talking to you guys. Professor Dawood, thank you very much for the assist, as you will, to my talk, because I think you are doing some really exciting work, but we're both trying to make cannabis boring again, right? So prepare for maybe the most boring talk of the day. How do you do that, making cannabis boring? You know, because for me, I love working with cannabis. I love working with the plants, you know, but for patients, it's actually better if cannabis is boring. And let me take you through that story. So, what does a patient ultimately need? Is it hype? Is it marketing? Is it high THC? Actually, it's none of that. It's consistency. That's what a patient truly needs. Because if the product is consistent, you can do proper clinical research with that product, and in turn, get the proof and the evidence that the health insurance companies need to pay for the patient's medicine. And of course, nobody wants to underdose or overdose, you know, especially patients. So on the left, that's where we are right now. And Professor Dawood is trying to change that, you know, as are we from a practical standpoint. And for us to change this, I was thinking, you know, can we engineer the perfect cannabis plant? And I think I know somebody who can, and he's in the room with us. And it's about the future of cannabis. So what I did, I asked AI, design me the perfect cannabis plant. Are you guys ready? Yes. Here we go. So this is indeed the perfect cannabis plant. It's symmetrical, you know, it's not too big, it's very efficient because it makes really, really nice flowers. So essentially, that would get you the same product, the same effect every single time. And as an industry, we've become really good at cultivating a plant, right? So we're using technologies in cannabis cultivation that some modern crops aren't even using. So in terms of technology, cannabis is right there. In terms of genetics, it's like tomatoes in the 60s. Right? It's still unstable. Right now, if you pop a tomato seed, you know, and your neighbor pops one of that same variety, you get the same tomatoes. You know, yours might be a little bit more sweet depending on the environment, etc. But essentially, the genetics are the same. So cannabis is, at this point in time, kind of in a weird place. Right? So 10 minutes to talk about the future of cannabis. I didn't know, when I proposed this talk to Ruben, he said, yeah, go for it. And on second thoughts, 10 minutes to delve into the future, kind of short. So as we are discussing, or going to discuss the future of cannabis cultivation, let's look at the last breakthrough, the last global breakthrough that is still meaning so much for cannabis. Any idea what that is? We have it in this room as well. And no, it's not AI this time. It is LED lighting. Because suddenly, you know, LED is not just a light source. It's an invention, so to speak, that allows us to fully control photosynthesis at every single part of the plant. So we can put lights down below, we can put lights in between the canopy, we can put lights very close to the canopy, we can have dynamic and spectral steering, you know. Intensities can ramp up. We have so much control on the photosynthesis process, right? And with this, it's like playing a video game. You unlock this level, you get a lot of rewards. Because suddenly you can unlock something that has been obscured in cannabis for a very, very long time, maybe ever. And that's the base plant architecture. So with that breakthrough over the last decade, looking ahead, what is next for this decade? I can tell you what's next. You're not going to like it. Base plant architecture. How do we get to this base plant architecture? By something that the industry has called sea of green or no veg, but actually it is direct photoperiod induction. This is a clone that was propagated until it reached roots. We didn't give the clone an additional vegetative phase like pretty much all of us do. We just put that straight into flowering. And what that does, and you're going to read about this pretty soon, hopefully in the peer-reviewed literature, what that does is essentially optimizes the plant to make it so that the plant doesn't build too much vegetative biomass. It builds just enough. And if you add the magic of LEDs that we can now place, you know, anywhere within the canopy, even on very small clones, you can kind of unlock that phenotypical and architectural uniformity. So that was with clones. This is what no-veg does with seeds. So this again is a seed plant that had no vegetative phase. So those seeds were germinated under 12-hour conditions. Yeah. And 0 plant touches. That's perhaps even the most important thing. So with both plants, clones and seeds, those are to scale, by the way. They're not the same variety, but just to make an illustration. So what we see here is cannabis for the lazy people, for the boring people, because there were no plant touches on either plant. The clone finishes up in 49 days since transplant. The seed takes about 70 days. The one thing that is critical with direct photoperiod induction is the planting density. And it is not so much as a horticultural technique. It's about a systems integration, because if you look at it from a pharmaceutical perspective, if you look at pharmaceutical production, the big value is upstream. It's where the process starts. And there's a system designed around it to make sure that you don't have to do corrective actions during that process. But no, what do we do in cannabis country? We're super smart. So it doesn't matter if the buds are not all the same size, because, you know, we got sorting equipment for that, you know. That's great. So we tend to solve problems downstream instead of making a good upstream architecture where propagation is important. So we have finished, Stefan Martin Meyer and myself, my team, we finished what would be the very first publication, peer-reviewed publication on no-veg or direct photoperiod induction in the scientific literature. We scoured the internet. We also use AI for scouring the internet. There is nothing in the scientific literature about this principle. And we don't propose it as a cure-all, fix-all. We propose it as an essential element of a systems-based architecture for pharmaceutical cannabis cultivation. And so this is what normally happens, you know. We put a plant in, we put it under these, you know, high LED light intensities, and everything gets absorbed by the big sinks of the plant on top. So a little light gets down below, which leaves you with a lot of larvae and fluff and, you know, great for making extracts, etc. But essentially it is waste. It is biological waste in a what would be a pharmaceutical system. So what do? Because we're so smart, we work hard. And the harder we work, the better it is, especially in cannabis. If you're a lazy cannabis grower, you're not doing a good job. I would argue the opposite. So what happens here, we give the plant the architecture that we want to get a canopy that's efficient. All the while, we're introducing variance into our cultivation system. Every time we take away a leaf, a wound appears. It creates risk, If you have cheap labor, it's okay if people have fun with that, but it's not a system integrator. So one thing that we can do now, not only with the baseline architecture of the plant, we can play around with the LEDs. And at this moment, we are actually doing a lot of work on under canopy lighting and showing that it even works without any top lighting in a greenhouse. So just the normal light of the sun. No more fixtures overhead that block the sun coming in from the greenhouse, because we're so smart. What do? We grow in a greenhouse to use the sun. We populate the ceiling with LED lights. We block out the sun. It's time to start rethinking about working smarter, not harder. So we don't need to fix the plant. We need to design the system. If you don't have a baseline or a perspective on a baseline, such as a basic plant architecture through direct photoperiod induction, it's very hard to design a system. Look at it as an orchestra. Everybody, before the orchestra starts playing, everybody needs to tune their instruments. If that doesn't happen, it's out of tune, no matter how well you follow the SOPs or the partitures of the music, So we need to design a system. This is a picture of a trial that we've got going on right now. So a no-veg trial with under canopy lights. And I can show you the latest pictures on my cell phone, what it does to the plant architecture, to the basic plant architecture. Because if we use veg in this, your veg is going to be different than mine, depending on the genetics. And we all do something different. I might have 6 main colas, you might have 4. But if you go with basic plant architecture, you can study a lot of things very precisely. Nutrients, irrigation, substrates, lighting strategies, dynamic lighting strategies, etc. So it unlocks a big treasure trove of future research. And it's about what we call not automation. That's so 90s, automation. Replace workers with robots. We're looking at automation. That's completely different. You're not only trying to save on labor to be more efficient, but you want a self-controlling and self-correcting system. So you don't need to go in and fix the mistakes if they happen. You need a system that can prevent mistakes. And the future of cannabis is not only in that basic architecture, it's also in lighting. Different lighting strategies, genetics, like Professor Davoud said, precision irrigation, climate control, and above all, AI. Because it's not a question of whether we get there, it's a question of when and how fast, and if we are prepared or not. And don't worry, man, the system learns. The system gets better. This is also a no-veg representation. The sparkly stuff is added with AI. Had to bring some AI in here. So you have to trust the system eventually, but you have to set your baselines that we can set right now. So all in all, we have to produce it right every single time, because that's what a patient wants. It's predictable, it's consistent, and above all, it is boring. Thank you very much.